Hello everyone, welcome to my next tutorial related to the BDF software. In our previous tutorial, we have already seen naphthalene TDFT result. In this tutorial, we will move towards the TDFT spin orbit coupling. So before start of this tutorial part, I want to introduce myself, Sahil Verma, working as application engineer, well-known company Impulse Technology. Number of the users available and our company which have partnership with HJW, Nanocadmic Technology and Flexim. We have different type of products. You can see in here, we will be focused on that BDF software. It is a quantum chemistry tool. In our previous sessions, we have discussed related to the time-dependent density functional theory. Who is new on this video, we can explain one more time. It is a quantum chemistry method used to calculate electronic excited state of molecules and materials. Generally, it is a extension of density functional theory, and basically it is used for the standard DFT that provide information about the ground states, and we can also study in here the excited state properties such as UV visible absorption spectra, excited energy, oscillator strength, electronic transitions, excited state geometry optimizations, fluorescence and fluorescence, non-adiabatic coupling and spin orbit coupling. We will be again take one of the example naphthalene, and in a previous session we have already only discussed about the TDFT, but in this session we will be focused on the TDFT spin orbit coupling. Like in the previous sessions, we have calculated different type of TDFT result, and now we will be calculate spin orbit coupling, SOC matrix elements like coupling strength between the singlet and triplet state. Singlet and triplet state, you can see near the ground state and singlet first excited state, triplet first excited state, like this. Straight interactions and ISC and RSC analysis like predict the intersystem crossing and reverse ISC, spin orbit coupling corrected states and transition dipole moment and fast frescence and TDF parameters. So basically we will take one of the example and one by one I will calculate TDFT SOC parameters. So now I'm going to open Device Studio where you can use BDF software. Once again I want to inform you that BDF supported Linux system. So Device Studio has a graphical user interface where we can create different molecule structures and create one of the input files. Who has not seen in my previous video, and check so you can understand what I want to say in here. You can open Device Studio and create a new project. Give in here your project name, Kathleen spin orbit coupling. In a previous video, you have already seen how you can calculate TDFT, but in here I will show how you can calculate a spin orbit coupling. So first you need to import molecule. Not only the naphthalene, you can import any one of the molecules. Like in here you can see import local 0D, different molecules have given. You can see if you want to import online, you can import direct different formats given in here. You can check. And if you want to create a molecule, so you can create from this molecule. You can see different molecules or ring fragments given in here, like R group fragments and biofragments, whole periodic tables. If you want to create your own selves, you can create from here. And not only this, if you move toward the molecule 2D, so you can also create in here like this different structures and you can apply. If you want to give hydrogens, remove implicit hydrogen, increase charge, or anything else that you can do in here, bond arrow. So this is the property that I have given in here. So directly you can import one of the naphthalene structures. You can directly import naphthalene in here like this and click apply data. Totally depend on the user which type of molecules they want to import. So you can import and just showing one of the tutorial. Then again move toward the simulator tabs, BDF, and you can see job title, input files, calculation type. We have already explained in the previous sessions like a single point energy calculations. You can optimize your structures, frequency calculations, optimizations plus frequency, time dependent density functional theory, time dependent density functional theory, spin orbit coupling, time dependent density functional theory, non-adiabatic coupling, TDFT optimization, TDFT frequency, nuclear magnetic resonance. So different things and calculation type given in here. I will focus on the TDFT SOC so you can select in here. Like you can see Hamiltonians they have changed it for that calculations parts. Method that have given different functional groups have given in here and they use dispersion corrections that means van der Waal interactions restricted for that closest system calculations basis all electrons and basic set that I've given in here charge multiplicity. If you want to change, you can change like plus minus like this. Point group. If you want to ignore symmetry, you can ignore. In the accept calculations, initial guess term maximum iteration that means accept convergence criteria that iterate your accept calculation 100 times. Convergence threshold tight, very tight, default. So depend on the users which type of settings. DFT integral grid level shifts. I'm just selecting the default parameters and it is the part of the TD and TDFT multiplicity number of the excited state. You can increase any other excited state. You can check if you want to increase your calculations and convergence parts. You can use this MPEC plus COSC accelerations. It means multiple expansion of column that help to increase the TDFT calculations. It will give the accurate results. So we are using this. And when you click on the previous scripts, you can check. The script has been created in here. If you want to change, you can change, and otherwise you can directly generate your file. With the help of machine options, you can connect with the BDF engine Linux system like this, and then you can click on the run. So you can check any other job manager files. It is stated in the queue. With the help of this putty, you can check your project Alex. Then you can add with the directory molecule. You can add again with the directory. Then you can run with this command bdf dot input dot out and click on the enter button. Calculation has been started. Calculation has been finished with the help of WinSCP. You can collect your result. You can copy like this and then at the same place you can paste where your projects given like this. You can see BDF.output files and BDF for the orbitals representations available in here. You can check your file. Like which type of functional group you have set, basic sets, and any other total energy of your molecule. If it is more negative, so it means that have too much stable. It is a molecular orbital interaction. In the BDF XCF files, you can check. You have choose restricted, so it is closed cells calculations given in here. Virtual means some orbitals they have empty and therefore they have the positive energy, and occupied they have the stables and not available. And it is a time dependent density functional theory result. You can check like this. TDFT result we have already discussed, so you can check our previous video. I will discuss any other TDFC spin orbit coupling results. You can check any other coupling matrix elements that unit they have given in here. That TDFT SOC means it used to check that spin orbit interactions in the excited states. What is actually effect? In the simple word, we can say it check the spin orbit interaction in the excited state, and you can check one by one like T1 and singlet ground state. And if that spin orbit coupling will more like this 1.79 or 1.27, that means if it will be more, so that means in the interaction between T1 and S1 is more, and like any other zero, that means no coupling, and we can select at the range like 0.01 to 0.1, that means some weak coupling that have, and 1 to 10, that means mid coupling. So like this you can represent, and in here you can check uh, spin projections quantum number, or also can we say spin magnetic quantum number, like ms equal to 0, that means spin projection will not change, and if we will move toward that one, that means spin projection can be changed, and it for the orientations like -1, totally opposite interactions for that one, and like T1 to S1, it is at the in here the inter-system crossing, RISC reverse intercrossings can be say. So different value you can check in here, like singlet ground state, singlet first excited state, and in between the T1 or S1s, how that's excited state, and the what is the actual interactions. So you can check in here. So it is the result basically, and when you go with this BDF XCF files, here you can check the molecule orbital representation, and if you want to export your project y-axis and x-axis, so you can check. When you move toward the BDF and UV visual spectroscopy, you can check their files, molar conductivity and oscillator strength. If they will be high, so that means it is high peak. So you can check in here the UV visual spectrum results, TD triangles and TDFT spinners. So we have that major focus on this TDFT spin orbit coupling results parameters in this BDF software. So who want to use this type of software, they can directly connect with us. They can comment, and at the end of this tutorial, I will attach my email if you have any query related to this. And who has not seen in my previous video, please check out the playlist. Not only the BDF software, we have multiple softwares, so you can check our projects with, you can check different product with that simple example. Thank you very much.